Let's suppose it's your first day at work and you have just arrived at the building and you're this green dot with the circle around you, and this orange thing is some floor and walls, right? And here's the lobby over here on the right. And you're trying to get to the lobby, and this is the entrance over here. Maybe there's a front door, and you've just walked in through the front door. And these are employees as well, these dots. So this colored dot, the first employee you encounter, tells you that you're running really late. You gotta absolutely hurry. And he also tells you to go down. This is the first direction you get as to how to get to the lobby. So you start running really fast downwards. Let's see if I can draw a straight arrow. I don't know, I'll approximate. So you're running really fast, right? Really fast down this way. And then you encounter this employee down here. Maybe he's the guy hanging out at the coffee pot or something. And he tells you, don't worry, take it easy. You don't have, you've got plenty of time. So you just kind of start strolling this way a little bit. You're not even really going that fast. And he also tells you to go to the right. He says, oh yeah, you got to go to the right and you don't have to go that fast. So you just kind of start strolling and taking your time. So here you're going slow. And then you reach this dot and he says, what are you doing? You're going to be completely late. So you start sprinting up here. So now you've got this, this is your sprint. This is even faster than the arrow than you were going on the left side. And then you encounter this employee, this blue dot, and he's the guy who's kind of gonna welcome you to the lobby and to perhaps where the other employees and such are. And he tells you, you're super late, but take your time, try to relax and cool down. So you try to walk in here with some bit of swagger, and you come in like this. And let's do that in a color you can see. Right. So this is you trying to show up late, but be cool doing it. So what I've done here is I've drawn arrows whose length is proportional to how fast you were going. And they're also pointing in the direction that you were going. So for instance, you knew to go down and then to the right and then up and then to the right. The employees were telling you where to go. So not only did you have some speed you were going really fast, or you're going slow, or you had to, absolutely run as fast as you could over here, but you also had a direction. So you had not only a number, some number, maybe you were going like 5 meters per second or something, but you also had a direction you were going. And so we call quantities like this that have a number or a size, you can kind of think of it, we call them vectors. So the most basic definition of a vector, and let's just write it out here. So a vector is a quantity that has both magnitude and direction. So what does magnitude mean? Well, magnitude is just the size. It's just a number associated with some quantity. So size / number, right? So let's say up on the top here, when you were absolutely sprinting on the right, you were, let's say you were going, I don't know, some ridiculous speed. Let's 10 meters per second. Why not? So you were going 10 meters per second. So that's this number, and along with the unit here, this is what we would call a magnitude. This is a magnitude right here. But you also had a direction when you were doing that. You were sprinting straight up the page for us, or straight, directly up that hallway. So you also had a direction associated with what you were doing, right? In that case, it was straight up for that example. So you had both a magnitude, both a size, a number associated with what you were doing, and a direction. So another example would be if you were just standing here, you were this person, and I told you to, walk a certain direction. So I also tell you how fast to do it, right? But let's use numbers now. So let's say, I tell you to walk 2 meters per second, but then I also have to give you a direction, because if I just tell you to walk 2 meters per second, you could pick any direction you'd like. So I say, go to the right at 2 meters per second. So you go this way, right? So that's all a vector is. And we generally show vector quantities as having, as being an arrow. That's how we represent them visually. So when we represent them as arrows, the length is basically proportional to the magnitude. So if the magnitude was 20 meters per second, it would be twice the length. Of course, when you're drawing it, not all, you don't always get these proportions exact, but, relatively, it's going to be twice as long as this one. And then you have the direction, which is just the direction that the arrow is pointing. So that's all a vector is. A lot of times you'll see quantities that don't have direction and magnitude, and those are just called scalars. So scalars, right? And they're quantities that just have a magnitude. Just have a magnitude. So examples are like mass and time. So you could say someone has a mass of 5 kilograms, or you could say that something like, 10 seconds have gone by. Whoops, that's a terrible zero. Something like 10 seconds have gone by. So those are just scalars. They're just magnitudes. This here is a magnitude over here. That's a magnitude. This is a magnitude, but there's no direction. You don't say I have like 5 kilograms in an easterly direction or something like that. That's just, you wouldn't say that because mass is a scalar. However, for quantities like velocity, kind of what I was describing up here, and in other cases where you actually want to have a direction associated with the quantity, then those are called vectors. So that's just the difference between a vector and a scalar, is that a vector has direction, whereas a scalar does not.